In this section, we will be studying the properties or rules of logarithms. The first three properties we will learn today will be used to reduce very long expressions with logs, called condensing, as well as unreducing shorter expressions with logs, called expanding. This may seem a little counterproductive, but there are some cases where we want to condense a log expression to a single logarithm, and sometimes we want to unreduce or expand short expressions so we can break up parts of the logarithms. So it's important to know how to both condense and expand. We will be learning three properties or rules that help us condense and expand. After that, we'll be learning one more property, and this last property will help us calculate estimates of logs using the calculator. The first log rule that we're going to talk about today is the product rule, which says if you have log base b of a product means we're multiplying two numbers or variables, m times n in this case, you can rewrite this as log base b of m plus log base b of n. Similarly, you can rewrite log base b of m plus log base b of n as the log of base b of mn. This is a forwards and a backwards rule. It can go either way. Now, some students look at this rule and are like, what? How in the world did you change a multiply into an addition of two logs? So I guess the question they usually ask is, where in the world did this come from? So when the students ask that question, I show them this. If you have x to the fourth times x cubed with just exponent rules that we've used in the past. If I have 4 x's being multiplied here times 3 more x's being multiplied here, we use the shortcut by adding the two exponents and getting x to the 7. Notice that I had a multiply to exponent problems, which turned into a sum of the two exponents. Similarly, I have a multiply of my argument, and this multiply, when I broke it up, because it's a log and logs are inverses of exponentials, that turned into the sum of two logs. So this isn't quite so far away from what you might have seen in the past, although it is a little weird writing with the log m plus log n. It can be a little bit foreign to students who haven't seen this before. So we're going to go ahead and practice this. We will first use the product rule to expand into more than one logarithm, and then we'll use it to condense down to a single logarithm. On the first problem, log base 4 of 7x, notice that the 7 and the x are being multiplied. So what I'm going to do is I'm going to break the 7 and the x into two logs. Log base 4 of the first part of the argument, 7, plus log base 4 of x. And that's my final answer. There's no more separating I can do. I've taken one log of one argument, and turned it into the sum of two logs. On our next problem, log base 8 of xyz, notice that I have 3 terms being multiplied inside my argument. Because I have 3 bases being multiplied inside my argument, I can change log base 8 of one argument into the log base 8 of the first part of the product, plus log base 8 of the second part of the product, y, plus log base 8 of the third part of the product, z. And this is the expanded form of log base 8 of xyz. The next thing I'd like to do is to use this rule to condense to a single logarithm. So notice that I have 2 logs in this question, and I'm trying to break them down into just one logarithm. So I would like this to be rewritten as just log base 4. Notice that the 4 and the 4 are the same. They have to be the same in order to combine the arguments using the product rule. Notice the b and the b base and this original b base all have to be the same base b. So these are the same base, so I rewrite them as the same base of 2 times 5. I changed a sum of logs into the log of a product. Now this 2 times 5 can be reduced, so I'm going to go ahead and reduce that to log base 4 of 10. On our last problem here, we have log of 25 plus log of 10. Are the bases the same? Well, yes, they are. The first base was an invisible base 10, the second base was an invisible base 10, so I'm going to leave an invisible base 10 on my answer. And I'm taking the 25 and the x arguments and multiplying them to get 25x. And now I've condensed both of these expressions down to a single logarithm. Our next rule is the quotient rule. The quotient rule is very similar to the product rule, but instead of multiplying in my argument, I have a division in my argument. So therefore, when I break it up into 2 logs, it's not going to be the sum of logs, it's going to be the difference of logs. Log base b of m minus log base b of n. Again, some students say, where in the world did this come from? And if you're asking that question, I usually respond with this answer. We have x to the 7 over x to the 3. If I have x to the 7 over x to the 3, that's like 7x's being multiplied in the numerator, 3x's being multiplied in the denominator. After I divide out a series of x's, I'm left with 4x's in the numerator. And the shortcut we learned was just to subtract the exponents and to get x to the 4 this way. Notice I had a division of 2 exponents, and it turned into a subtraction to get my answer. So conversely, with the logs, when I have a division in my argument, I can break that up into 2 logs using a subtraction sign. So this isn't quite as far off as we might have thought, but it may take a little practice to get used to. So on our first 2 examples, my instructions say expand. So I want to expand this into as many logarithms as I can. Inside the argument, I only have 2 unique bases. So in this case, I have log base 7 of my numerator, which is 19 in the argument, minus log base 7 of the denominator of the argument, x. There's no more expanding that I can do, and this is my final answer. On my next problem, notice I'm using ln, and because I have the property ln, that's an invisible base e, I'm not going to go ahead and write that. I'm just going to make note that it is an invisible base e when I use natural logarithm. Natural logarithm of the numerator, e cubed, minus natural logarithm of the denominator, 7. And now I have expanded this as far as it can go. Although you have expanded using the quotient rule, there is one more thing you can do to reduce, and the place that you can reduce is on this first logarithm. ln base e of e to the 3. Whenever you have a base e inside the logarithm and a base inside the argument, the ln base e and the base e of the argument cancel each other out, and you're just left with 3. That was a property that we learned in the last section. Another way of thinking about that, if you forgot, is if there's an invisible base e, you're thinking to try to evaluate this in your head, e to the what equals e cubed? And the answer here is, well, 3. E to the 3 equals e to the 3. So therefore, ln e to the 3 is just equal to 3. Or you can think about it as the ln and the e are inverses of each other, and so they cancel each other out, leaving you with a normal-sized 3. That one was a little tricky. After we learn a property, it's fair game to come up in any of the problems in the following section. So it's important that you learn your properties because we will be using them both in this section as well as the solving section. The last thing that we're going to do with our quotient rule is to condense. I guess more specifically we'll say condense to a single logarithm. So I have two logarithms, and I'd like to condense down to a single logarithm. I note that the sign or operation between the two logarithms is subtract. So because it's subtract, I am using my quotient rule, which says I have log. Notice my bases are the same, base 10, so I don't have to write it, of the argument on the first term, which is 4x minus 3, divided by the argument of the second term, which is x. I have now condensed this down to a single logarithm. I cannot reduce inside my argument, so that's my final answer. On this next problem, we have log base 4 of 16 minus log base 4 of 2. Notice the bases are the same, so in my answer, I'm going to have log base 4 as well. I notice that the operation between the two logarithms is subtract, and because it's subtract, that means I'm using the quotient rule, which tells me that I'm going to divide the two arguments. The first one is the numerator, the second one is going to be the denominator. Now 16 over 2 reduces to log base 4 of 8, and for now that's as simple as we can do. In the next video, we'll be talking about the power rule and the change of base rule.